Hey guys, welcome to DSA-n-Design. And in the previous problem, I think this was the same problem where we were actually trying to solve the range sum query, right? And within that range sum query, we actually were able to solve it, but that was not very optimal solution, right? So we were actually getting space complexity was constant and time complexity was basically order of n into q. Given q are the number of queries here in the B array, right? But now this time complexity was very high. So what we said is we will try to optimize in the next session, which is this video basically, right? So let's try to see how we can optimize this particular query. Okay, basically this particular problem, right? I mean, we want to definitely bring down this time complexity because this is very higher and this will definitely give you TLE, right? So let's try to basically see the approach, right? So what we can do is, I think um, we can do one thing first of all. Let's try to take this array, okay? So this is my array 1, 2, 3, 4, 5 and make a cumulative sum, and this is called prefix array. Okay, so what I'm going to do is I'm going to create a prefix array which is going to be a cumulative sum, which is 1, and then I add up 1 to 2 equal to 3, and 3 plus 3 6, 6 plus 4 10, and 10 plus 5 equal to 15. Okay, so this is nothing but cumulative sum of this particular array, right? Now can we do something about it, right? So let's say if I want to, now this is my cumulative sum. Now what I will do is I will basically take this index, right? No, now let me take different colors so we can actually find it. So this is my index 0, 1, 2, 3 and 4. Okay, now what I have to find it basically, let's say I want to find L equal to 0 and R equal to 4. Correct, this is my query, first one, let's say, right? In this case, uh, can I have a formula, right, for sum which can say that pf of right minus pf of left minus 1, all right, on this basically, right? And let's see whether this is actually fitting, right? So sum basically, right? Now sum equal to pf of r, which means basically on the fourth, which is 15, right, minus pf of L minus 1. So L is equal to 0, right? And L minus 1, if I say, it is not going to work, right? So in this case, I think the formula will be, this is, okay, formula can be something like this, okay? Uh, uh, Something like this. Just pay attention, guys, okay? This is except L actually, except 0, right? If, okay, let me put something. If L equal to 0, right? Then sum will be pf of r, okay, else, correct, sum will be, simply pf of r minus pf of L minus 1. All right, now in this case L equal to 0, because L is 0 clearly, that's why it is not going to be anything, so it is going to be only 15, right? And which is exactly here, right? This is the answer. Now if, can I try to solve this one, 1 and 3? Okay, let's try to see if this is fitting. 1 and 3, L equal to giving 1 and R equal to 3. Okay, now L equal to not 0 definitely, so this particular else part will come actually. So sum will be pf of R basically 3 minus pf of L minus 1, which is 1 minus 1, correct, which is pf of 3 minus pf of 0, right? And what is this value actually? Pf of 3 is what, guys? 0, 1, okay, so let me show you also here, right? So pf of 3 equal to 10, right? Pf of 3 equal to 10. 10 minus pf of 0 equal to 1, which is 9, correct? And let's see if we are getting the answer. And we got exactly the same answer here, right? This particular solution is very, very optimal, right? Okay, and this is called what? This is called prefix sum. Prefix sum basically array, prefix sum array, right? So this is the technique, right? This is called the prefix sum array. Okay, prefix sum array technique to solve this particular problem. Now if you look at this particular coding, right, how, okay, so let's try to do one thing. Let's try to code it directly, okay, in IntelliJ, and try to see actually what is the time complexity. Now, let's not talk about time complexity. I hope that you got the idea how we have to do it, right? Now, let's go here and we will try to, I will, okay, what I can do is I can actually copy this same question, okay, here, and we will modify within this, okay. So I'll say range some query using prefix sum, okay. Prefix sum is okay, okay, 1 second guys, why it's not okay. Okay, now we got this, right? All right, so we are here. All right. mm, 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 mm. Remove this part, okay. Now I will show you where exactly we need to do the changes right now, okay. So here, first of all, we need to create a prefix sum. Agree? Okay. So let's create a prefix sum here, okay. So I'll say int pf equal to new int and n. Prefix sum will be same as my normal array, right? Array A. Now I'll create this prefix sum, and how we will create it. Basically, I will say I'll start basically from int I equal to 0, okay, and I equal to n and I plus plus. Okay, let's do one thing. Okay, so prefix sum, what basically we do, we actually keep adding the element, right? So this is the logic. Okay, pf equal to I equal to pf I minus 1 plus a of I. Okay, I'll show you what it means, right? This is the logic for the prefix sum. Okay, now what we will do is let's try to, okay, so this one definitely we don't need it. We don't need this particular thing. We don't need this particular thing. Why? Because we will be able to solve it in a single loop actually. Okay, so that is done. Now we got the prefix sum pf, right? Now we will be operating everything. Now we got left and right. Okay, now if I say answer idx plus plus, okay, now answer will say that so one here is answer before that, no. So if L equal to 0, no, that in that case, okay, I think it's only single element, so single formula. So I can say answer will be idx plus plus and pf equal to r. This is what we have seen, because in case L equal to r, in that case L minus 1 cannot happen, right? It will go in the minus, right? Otherwise, right? Answer idx, okay, idx, this will be having the formula called pf r minus pf of L minus 1. Okay, this was the formula. We have looked at it, right? So, and okay, fine. So this is the thing, right? This is what exactly we have to do. There is no other changes, right? Let's try to see if we are able to run it actually. Okay, just bear with me because this is not a very simple logic, guys. Okay, this is uh, okay. Let me, why not? 1 second, guys, just give me a second. Range some query, why it is still picking range some query? I just need okay, let's see if I can. mm, no, why it's not coming? Okay, fine, let's see if I can just run it again. If it is not okay, so let me just close this as well. Why it is creating some problem? Range some query, okay, I don't really need this range some query. Why I'm not able to? Okay, give me a second, guys. Okay, right, this is my current file. Okay, and no, actually run with parameter. Now I think I should be right? Just give me a second. It's okay. Can I do one thing? Let me, I don't know why it's picking again and again. Let me delete it. Okay. And let me close other programs as well because they are creating problem looks like. Now I have this single. Hmm, now this should work. All right. So this is working, but there is some issue. What is that issue? Index -1 in the line number length. Okay, 11. What is the problem? Ha, oh, oh, oh. Actually, we are starting with 0 and we are saying 0 minus. So this is invalid index again, right? We have this array -1 index is not there. So I'll start from 1. And to start with, right, the first element PF of 0, like cumulative of the very zeroth element, the first element is always going to be the same. We are not going to add the very first element with anything, right? Now this should work, guys. Okay. All right, we got the answer like 15 and 9. This was the same thing, right? Now you see the magic here, right? Because see, we actually created a cumulative array for, first here, and this is also called the prefix array, right? Prefixum array, what we are going to do is basically we are going to add up each and every element and we are going to store in the prefix array, right? And inside this, we are coming and we are using this particular formula, okay? Okay, I think once you do once and then you try to dry run, you will be able to understand. But for the sake of not having the longer video, I'm just kind of just giving you this idea, right? So now hopefully you are able to understand. If you want me, if you're not able to understand, please comment in this video. I will be doing a detailed video. How much time it might take, maybe half an hour also. That's fine with me. But I will do very, very detailed video and will be proper example and everything, right? Because we have the time limitation here. So I'm not actually extending this video. But if you really need it, you let me know. I'll do a video that will actually give you a lot of clarity, like everything. But I think this is the logic, right? First you create a prefixum and then on that prefixum you apply this formula basically, right? Okay, and this will perfectly work. Okay, so this is the optimized way. Now let's try to look at the time complexity. So if I look at the time complexity, here we are actually running in this for loop n time, and here we are actually running q time, right? In this for loop. So these are not kind of nested for loop, they are separate. So basically time complexity in this case, space complexity is going to be same. Time complexity is n plus q, right? This is going to be n plus q time complexity, right? So this is what actually I wanted to tell you, right? So this is time complexity n plus q, okay? This is very, very less complexity. In previous was n into q, right? That was the problem. Okay, so that's all for this video, and I'll see you soon with the next video, guys. And stay tuned here. And if you are first time visiting this channel, please do subscribe it, support me so that I can bring more and more such amazing content for you, right? And yeah, so we are actually good with this video. I'll see you soon with the next video. Until then, happy learning. God bless you. Bye.